If we look at the expand and simplify, right? And if we look at the exponent law, I should get the same answer. Right, if you look at the first one, I got a squared and a squared for both of them. If I look at the second one, I got a and a. If I look at when I have a to the power of 3 divided by a to the power of 3, when I expanded, I got 1. But when I use the exponent law, I got a to the power of 0. What that means a to the power of 0 is equal to 1. Okay? Now that's a whole new law that we're going to talk about. But let's look at the other ones. Okay? The other one says, so for example, when I have a to the power of 3 divided by a to the power of 4, I got, with using the exponent law, I got a to the power of negative 1. But when I did the expand and simplify, I got 1 over a. Then here, I got a to the power of negative 2. But that's 1 over a to the power of 2. A to the power of negative 3, which is 1 over a to the power of 3. A to the power of negative 4, which is 1 over a to the power of 4. Why do you think that is? Or how can I do that? What's the correlation between the negative exponent that I'm getting and if I do expand and simplify? So what happens here is whenever you have a negative exponent, you can flip the base and make your exponent positive. So if you look at this, right here, base right here is 1. If I flip the base, that becomes 1 over a, and I can make my exponent positive. Because technically in math, we don't leave our exponent as a negative exponent. Okay? So you flip the base and make your exponent positive. Are we okay with that? That's a law. Okay? Which is the negative exponent law. Right here. And then we have the zero law. So with the zero law, any base, doesn't matter what it is, to the power of 0 equals 1. So let me give you an example. If I have, let's say, x, y to the power of 0. That's equal to 1. That's it. You stop. You say 1, stop. That's it. That's your final answer. Because any base to the power of 0 is equal to 1. Okay? And the reason for that, if you look at when did I get a 0, I get a 0 when both the numerator and the denominator had exponent, right? I had the same exponent, so a cubed divided by a cubed. If I divide something by itself, it's going to give me 1. And if I subtract the exponent, that's going to give me 0. That's why. It's always going to happen. Whenever I'm dividing something by itself, that's equal to 1. And if I subtract the exponent, they're equal to 0. And then with the negative exponent law, it says so I want you to apply this law last, unless you can't do anything. So let's say if you have x to the power of negative 3, y to the power of 2 over x to the power of 5, y, something like this. Don't flip this at the beginning, okay? Leave it till the end. Do your other exponent things, do your other simplification, then flip if your final answer have a negative exponent, okay? But if your negative exponent is on the outside like this, then yes, flip your base, make your exponent positive, then distribute.
If it
Okay? So if it's inside where on top of a letter, just a letter, then leave it till the end. Don't flip at the beginning. Okay? If it's on the outside, flip first, then do your other math. Okay? Take only the base with negative power and switch its placement. So let me show you what I mean by this. So let's say if I ended up with something that looks like this. X negative 2 y over w squared. Let's say I have this answer. Okay? This is my final answer. I have nothing else I can simplify. Okay? Can I simplify anything? Can I multiply, add, do anything to the exponent? No, because they're all separate bases, right? They're all different bases. So because you look at the x has a negative exponent. Okay? Because the x has a negative exponent, what I do is I bring the x to the denominator, and that becomes y over x squared w squared. So you change its placement from the numerator to the denominator, and you make it a positive exponent. Okay? But I would do this at the end when I can't do anything anymore. Let's look at some examples. Let's look at this one, for example. The g, yeah. So I have 5x squared y squared to the power of 2 times 5 to the power of negative 2 x to the power of negative 6 times y. Bedmass have to follow here as well, okay? So what's the first thing I want to get rid of here? The exponent, right? You see that exponent 2? You want to distribute it in first, okay? So if I distribute that 2 in, what do I get? 5 to the power of 2, x to the power of 2 times 2 is 4, y to the power of 4. Now, I have multiplication. What do I do when I have multiplication? What do I do with the exponent of the same base? Add them. So 5 to the power of 2, eyes on the board for a second. 5 to the power of 2 and 5 to the power of negative 2, I add their bases. What's 2 minus 2? So that's 5 to the power of 0, right? Because I have 2 plus minus 2. 2 plus minus 2, that's 0. Now, I have x to the power of 4 and then x to the power of negative 6. Add the exponent, what does that give you? Negative 2, yes? So that's x to the power of negative 2. And then I have 4 plus 1, so that is y to the power of 5. Is there anything else that I can do with this answer? Can I still simplify? X has a negative exponent, so I want to bring it down to the denominator. That's right. And what's 5 to the power of 0? 1. So basically, this is a 1. And that becomes y to the power of 5 over, bring this down to the denominator, it becomes x to the power of 2. So that's my final answer. It's 1, right? Do I need to write a 1 here? I don't, right? Sometimes you have to write a 1. It depends if you're adding or subtracting. But in this case, if I write the 1 right here, it's not going to make a difference for me. Yeah? Yep. So I want you guys to try H. Try all of them.